Welcome to our comprehensive overview of machine learning, one of the most transformative technologies of our time. Let's dive into what makes ML so crucial. First, let's establish a clear understanding of machine learning. Machine learning is a subset of artificial intelligence that enables systems to learn and improve from experience without being explicitly programmed. From early statistical models to today's complex neural networks, ML has rapidly evolved, driven by advancements in computing power and data availability. So why is machine learning such a critical field right now? It's all about impact and capability. ML is revolutionizing industries, from predicting diseases in healthcare to detecting fraud in finance and optimizing logistics globally. Data is the lifeblood of machine learning. High-quality, vast amounts of data are essential for training robust and accurate ML models. Machine learning generally falls into three core categories, each serving a different purpose. Supervised learning uses labeled data to train models to make predictions. Think classification or regression tasks, like identifying objects in images or predicting stock prices. Unsupervised learning works with unlabeled data to find hidden patterns and intrinsic structures. Common examples include clustering and dimensionality reduction. Reinforcement learning trains an agent to make a sequence of decisions in an environment to maximize a cumulative reward, often used for training autonomous systems and games. Let's examine some of the foundational and advanced techniques that underpin modern machine learning. Neural networks, the basis of deep learning, are complex architectures inspired by the human brain, allowing models to learn highly intricate features from large datasets. Beyond deep learning, fundamental algorithms like decision trees, support vector machines, and k-means clustering remain essential tools in the ML toolkit. Creating a successful machine learning model involves a structured, iterative process. The first step is data preparation, cleaning, normalization, and crucial feature engineering, which transforms raw data into a format suitable for the algorithm. The process involves rigorous training on data, careful validation to tune parameters, and final testing on unseen data to assess real-world performance. Despite its power, machine learning faces significant challenges, but the future is brimming with potential. We must prioritize ethical considerations, addressing bias, transparency, and accountability to ensure responsible and fair development of AI systems. Key emerging trends include MLOps for streamlined deployment and Edge AI, bringing powerful models closer to data sources on devices. Machine learning is not just a technology, it's a foundation transforming every aspect of our lives. Stay curious and keep learning about this dynamic field.